So here we are going to be using the sum and difference formulas to simplify our equations. So the only time this can really be difficult is if they give you a single term. So if you notice, all of these equations have u plus v or u minus v here in this parenthesis, right? But you can see on number 1 and 2, instead of u plus v or something plus something or something minus something, they wrote it as a single term. So in those cases, it's up to us to determine what would have given us that value. So maybe we are looking at our values from quadrant 1, since 75 degrees is less than 90 degrees, had to have all come from quadrant 1. I'm asking myself, what could I maybe have added to get 75 degrees? Well, in quadrant 1, we got 30, 45, and 60. Just so happens 30 plus 45 is 75. So this would be equivalent to cosine of 30 plus 45 degrees, which if I look at our box from up above, that would be this formula, that would be this formula right here, cosine of u plus v. So since it was given to me in this form, I am just going to expand it and write it using that formula. So I'll have cosine of u, our u is 30, times cosine of v, our v is 45 degrees, minus sine of 30 degrees times sine of 45 degrees. And then I just simplify. So this is where we do need to remember our ratios from the unit circle. Cosine of 30 degrees would be square root of 3 over 2 times cosine of 45 degrees is square root of 2 over 2 minus sine of 30 degrees is 1/2 times sine of 45 degrees is root 2 over 2. So I multiply my fractions here. Square root of 3 times square root of 2 is square root of 6 over 2 times 2, which is 4, minus 1 times root 2 is root 2 over 2 times 2 is 4. We do have a common denominator, but root 6 and root 2 are not like terms, so I can't actually combine them, but I can put them over our common denominator of 4. All right, for number 2, we have pi 12ths. So now I'm thinking to myself, pi 12ths is smaller, right, than our pi thirds, pi fourths, pi sixths, so we probably subtracted to get pi 12ths. So I'm thinking to myself, I need a common denominator of 12. Okay, so I need something minus something that would give me 1/12. So maybe we use pi thirds and pi fourths. I do need to make sure that I get a positive pi 12ths, so I need to put the larger one first. So that'd be pi thirds minus pi fourths. So this would really be 4 pi 12ths minus 3 pi 12ths, and 4 pi 12ths minus 3 pi 12ths is in fact 1 pi 12th. All right, so now I just need to look at my table from up above, and I can say that pi thirds minus pi fourths for my sine means I want to use this formula right here. So I'm going to have sine of u, pi thirds, times cosine of v, pi fourths, minus cosine of pi thirds times sine of pi fourths. So now, just like last time, I just need to replace and simplify. Sine of pi thirds would be root 3 over 2. Cosine of pi fourths is root 2 over 2 minus cosine of pi thirds would be 1 over 2 times sine of pi fourths, which is root 2 over 2. So I'm going to multiply my fractions here. I get root 6 over 4 minus root 2 over 4. Again, not like terms, but I do have a common denominator, so I can put them over that denominator of 4. And that's as simplified as we'll be able to get it here. All right, number 3, this one's a little bit different. They did tell us what U is and what V is. But instead of writing it in that condensed form, they already have it expanded. So we have sine, cosine, minus cosine, sine. If I look up here, that is the formula that I already highlighted in blue right here. So if I want to write it as the condensed version, I'm rewriting it like this. So sine of U minus V. So sine of U, which is 42 degrees, minus V, which is 12 degrees. Those are like terms, so we can combine them in that parenthesis, and we're left with 30 degrees. And we know that sine of 30 degrees is equivalent to 1/2. For number 4, here I've got cosine of U minus V, so that would be the 4th equation up here. So that'd be this one right here. Cosine of U minus V. So I'm going to expand it out and write it like this. So I'll have cosine of U, which is theta, times cosine of V, which is 3 pi halves, plus sine of U, which is theta, times sine of V, which is 3 pi halves. And I'm hoping to prove that this is equivalent to that negative sine of theta over here on the right side. So if I don't know what theta is, I can't replace it. But I do know what 3 pi halves is. So on our coordinate plane from our unit circle, I know that 3 pi halves is down here at the coordinate point 0, -1, where this is x and y, and we know r is always 1. So again, we don't know what theta is, so cosine of theta stays. But cosine of 3 pi halves, cosine is x over r, would be 0 over 1, or just 0, plus sine of theta. We don't know theta, so can't replace it. But sine of 3 pi halves, which is y over r, would be -1 over 1, or just -1. So we're going to simplify over here. Cosine times 0, anything times 0 is 0, so that's gone. And then sine times -1 would just be negative sine of theta. So we have, in fact, proved that the left side is equivalent to the right side. All right, on the back. Here, it says, given that 195 is equivalent to 225 minus 30, so U minus V, they told us U and V here, we're supposed to find sine of 195, cosine of 195, and tangent of 195 using the sum and difference formulas. Well, they just told us it came from U minus V, so we're going to be using the difference formulas here. So starting with sine, I've got sine of 195, which is really 225 minus 30. And when I substitute that into the formula, I'm going to have sine of 225 cosine of 30 minus cosine of 225 times sine of 30. Well, 225 degrees is in quadrant 3. So we know that everything in the other quadrants is just repetitive of what happens in quadrant 1. So we realize that 225 is only 45 degrees greater than 180. So it's a reference angle of 45 degrees. And so I think about sine of 45 degrees. Sine of 45 degrees is root 2 over 2. But we keep in mind, all students take classes. I'm in quadrant 3. Sine is negative in quadrant 3, so I would need to make that a negative ratio. Times cosine of 30. Cosine of 30 would be root 3 over 2 minus cosine of 225. So really a reference angle of 45. Cosine of 45 is root 2 over 2. Again, I'm in quadrant 3. Cosine's negative there, so we make it negative. Times sine of 30, which is 1/2. So we multiply these fractions and we get negative root 2 over 4. Multiply these fractions, we get negative root 2 over 4. Oh, that first one, I apologize. That's negative root 6 over 4 over here. And we're supposed to be subtracting. So I do have a common denominator, so I can subtract, but I notice I've got 2 negatives here, which really means we're going to end up adding. So I'm going to end up with negative root 6 plus root 2 over 4. All right, cosine of 195. So this would be cosine of 225 minus 30. All right, so for our cosine formula, that would be cosine of 225 cosine of 30 plus sine of 225 times sine of 30. Well, we already discussed in the previous example that cosine of 225 is negative root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 225 is negative root 2 over 2. And sine of 30 is 1/2. So we multiply these fractions and we get negative root 6 over 4. Plus, when we multiply these, we have negative root 2 over 4. Again, we've got that common denominator, so I'm going to add those. And we end up with negative root 6 plus negative 2, or just minus 2 over 4. All right, then last one in this row, we've got tangent of 195, or tangent of 225 minus 30. All right, so for tangent, our equation from the front page for difference of tangent is tangent of u, which is 225, minus tangent of v, which is 30, over 1 plus tangent of 225 times tangent of 30. And now we're going to replace and simplify. So tangent of 225, we already said 225 is a reference angle of 45, so I'm looking for tangent of 45 degrees. So we should know tangent would be root 2 over 2, or just 1, anything over itself is 1, minus tangent of 30. Tangent of 30 would be 1 over square root of 3, but we know we can't leave a radical in the denominator, so we have to rationalize by multiplying top and bottom by square root of 3, which is going to leave us with square root of 3 over 3. In the denominator, I'll have 1 plus tangent of 225, which we said was 1, and tangent of 30, which we decided was root 3 over 3. All right, so in the numerator, I do want to be able to subtract these, so that would mean I need to give my 1 something with a denominator of 3, so I have a common denominator. So I can turn 1 into 3 over 3, so it has a denominator of 3, minus root 3 over 3, and then I can do the same in the bottom. So I'd have 3 over 3 plus, right here, 1 times root 3 over 3 is just root 3 over 3. So I've got 3 minus root 3 over 3 over 3 plus root 3 over 3. And now that I have a fraction divided by a fraction, I keep, change, flip. So I'm going to keep my 3 minus root 3 over 3, change to multiplication, and flip that second fraction over. So I already am going to see that I can mark out those 3's. That'll simplify. And I'm left with 3 minus root 3 over 3 plus root 3. And we don't like to leave radicals in the denominator. So while I could just multiply top and bottom by square root of 3, that still would give me a square root here, right? Because I have to multiply the entire denominator. So we're going to do something that we learned in Algebra 2, which would be to multiply by the conjugate. So basically, multiply by itself, which would be 3 plus root 3, but opposite sign because we want things to cancel out. But if I multiply the bottom by that, I also would have to multiply the top by that as well. So I'd have 3 times 3, which is 9. 3 times negative root 3, which would be negative 3 root 3. Negative 3 times 3, again, negative 3 root 3. And negative root 3 times negative root 3 would be positive 3. All over, same thing down here. 3 times 3 is 9. 3 times negative root 3 is negative 3 root 3. 3 times root 3 would be positive 3 root 3. And root 3 times negative root 3 is negative 3. Now we've got some like terms we can combine. So these two would be like terms, and these two are like terms. So I end up with 12 minus 6 root 3 over here, negative and a positive 3 root 3 to simplify out, and I'm left with 9 and negative 3, which is 6. And then I can simplify my fraction. So here and here are divisible by 6. That becomes 1. That becomes 2. I'm left with 2 minus square root of 3. And that 6 in the bottom simplified out. All right, so for number 6, I've got sine of 140 cosine of 50 plus cosine of 140 times sine of 50. So if I look back on the front page, sine, cosine, plus cosine, sine, that's going to be this formula up top. So I'm going to rewrite this as sine of u plus v, where where u is 140 and v is 50. So I've got 140 plus 50 like terms, which is going to give me 190. Now, 190 is not something that we have memorized on our unit circle, so that is where we will leave it. For number 7, it says find the exact value of the trig function where sine of u is equal to negative 3/5 and cosine of v is 24/5. Okay, so what I need to remember is that since both of these are in quadrant 4, I know my sines in quadrant 4. So I'm going to draw, this triangle is going to represent this one. So this is for u. So I'm going to draw me a little triangle here. All right, and we know that sine is y over r. So y must be negative 3 and r must be 5. So the only side I don't know is x, and this is actually a Pythagorean triple, so I should know that side is 4. All right, and now I'm going to draw another triangle to represent this one here. So this one is for v. And for v, we are told that we have cosine. So this is x over r. So x must be 24, r must be 25, so this side must be 7, and we know in quadrant 4 it's a negative 7. All right, so here it asks for sine of u minus v, so this would be sine of u cosine v minus cosine of u sine of v. All right, so sine of u, that would be the first triangle we drew. Sine of u is negative 3/5 times cosine of v, which comes from this one, would be 24 over 25. Minus cosine of u, cosine would come from this, that'd be x over r, so that would be 4/5 times sine of v, sine would come from this one, that'd be y over r, negative 7 over 25. So we multiply these fractions and we get negative 72 over 125 minus, we multiply these fractions, we get negative 28 over 125. We do have a common denominator, so I can add those together. These two negatives become a positive. It's negative 72 plus 28 is negative 44 over 125. All right, for cosine of u plus v, this would be cosine u cosine v minus sine u sine v. Well, we already know all these values. Cosine of u, coming from that first triangle, is 4 over 5. Cosine v from our second triangle is 24 over 25. Minus sine of u from the first triangle is negative 3 over 5. Times sine of v from the second triangle, which is negative 7 over 5 over 25. All right, so we multiply these fractions and we get 96 over 125 minus over here, I'll get 21 over 125, and 96 minus 21 is 75 over 125. Now, unlike our last problem, 75 over 125 should simplify down. It's going to simplify down to 3/5. All right, and then last one is tangent. Tangent difference formula is tangent of u minus tangent of v over 1 plus tangent of u tangent of v. All right, so tangent from the first triangle would be negative 3/4 minus tangent from the second triangle is negative 7 over 24 all over 1 plus negative 3/4 times negative 7 over 24. All right, so we will need a common denominator in the numerator. So I'm going to multiply this by 6, which would give me negative 18 over 24. And two negatives are going to make that a positive 7 over 24. So when I add those, I get negative 11 over 24. In the denominator, this will be 1 plus, when I multiply these fractions, I get 21 over 96. So I'm actually going to make that 1 a 96 over 96, so it's a common denominator. And 96 plus 21 is 117 over 96. And now I have a fraction within a fraction, so I keep, change, flip. So I keep my negative 11 over 24, change to multiplication, and flip that over to have 96 over 117. When I multiply these, I get negative 1,056 over 2,808, which will simplify down to negative 44 over 117.